Hi guys, so we are going to go over what we completed in class in terms of running an independent samples t-test, but we're going to cover mainly how to solve for it using all the math, such as like finding the comparison distribution, putting the numbers together, finding our degrees of freedom, and then potentially rejecting, failing to reject, and so on and so forth and all. So I'm just going to run through the data set just like we did in class, and we're going to run through these specific four steps. So the first one is we're going to do the biggest math part, which is the characteristics of comparison distribution. Essentially, we're going to find variance and the pooled variance, and then your S difference. So that's our goal, is to get to S difference. So we have group 1 rating of a chocolate bar that we told them it was worth $2, and then here's their rating. And then we had a group 2, they had the same chocolate bar except we told them that this one was worth $10, and so here's their ratings. So now we're going to just go ahead and put these numbers into work. So for the first grouping here, I'm going to go ahead and add group 1's data, and then for the second grouping I'm going to go ahead and add group 2's data. Okay. So I'm just going to simply move that data in no particular order into our data set. Okay. And then I'm going to just go ahead and move group 2's into the data set as well. Okay. For the second column, you're going to find the mean. So I'm going to actually go ahead and move this down a little bit. I'm going to add another row to be able to add for my mean. So this is going to be equals the average of everything that's in your first column. I'm going to go ahead and do that. Same thing for group 2. So you should have had a mean of 3 for group 1, or your X, and then 6.8 for your group 2. For the second column, you're going to take every X, and all you're going to do is you're going to go ahead and subtract that the mean. Now I'm going to go ahead and do the same thing to the other side. For your third column, you're going to take everything in the second column and you're going to go ahead and square it. Oops. And I'm going to go ahead and do that for our second grouping as well. Great. So then now you want to find the sum of everything in the third column. Okay, so essentially you should be left with the mean of X, the sum of X, the mean of Y, and the sum of Y. Okay, so that's our goal. That is where we want to get to in this problem. Now, in this part right here, you're just going to put the sum of X number that you got, which is 16. On this side, I'm going to do for Y, which is 10.8. Our n minus 1 for this one would be how many n, or sample size, there is for group 1. So that's going to be 6. So 6 minus 1 is 5. And then for this one, there's 5n, so 5 minus 1 is 4. Now all you're going to go ahead and do is you're going to just go and divide the sum of the squares divided by n minus 1. So equals sum of squares n minus 1. Okay. So now for S2x and S2y, so the variance of x and the variance of y, you should have 3.2 and 2.7. We're going to hop on over to the degrees of freedom. For our degrees of freedom, it's a little bit different from the single sample t-test that we did and the paired samples t-test. We're going to actually find df total. To do that, we have to find the individual df's of x and y. So for df of x, how many people were there? There were 6. 6 minus 1 is 5. And then for dfy, there was 5. 5 minus 1 is 4. df total is simply going to be this one plus this one. Okay, so equals this plus this, and you should get 9 for your df total. Okay, now we'll scroll down, and for this one, now you're not solving for anything additional. You've already did so much of the work. It's just a matter of popping in the numbers. So our dfx is 5, our df total is 9, and our S2x is 3.2. Our dfy is 4, total 9, and S2y 2.7. Now, all I'm going to do for this equation is I'm going to solve for this part first, and then I'm going to solve for this part, and then I'm going to add it together right here under variance pooled. So to solve for this, it'll be equals, open parentheses, your dfx divided by your df total, close parentheses, times your variance of x. And then for your S2y, same thing like we did in the last part. Okay. So this is what you should have. And then S pooled is just going to be these two added together. So equals this plus this. Now, moving it down. Now for this part, which is the next part of the equations, you're just going to bring your S pooled number and you're going to put it in here. Your n of x and your n of y, that's just how many people or rows of data that you have in each group. We know that we have 6 for x and 5 for y. So I'm just going to use this again, the same formula that's listed here. So I'm going to do equals our pooled variance divided by 6 equals pooled variance divided by 5. So essentially you should have 2 of these. Now bring this over here. I'm going to bring this one over. And now S difference is going to equal to this plus this. And S2 difference, sorry. And then S difference will equal the square root of your S2 difference. Again, I'm just following our equation here. Okay, so now you have your S difference. This is what you need in order to solve for our t-test. Before we do that, we're going to locate our critical values. So we know our df total was 9. So we're just going to locate the 9 and then locate it on a two-tailed test with 5% of error. So that's going to be 2.262. So I located 9 and I went to the two-tailed columns and I went to the 0.05 column and I just lined it up and it's 2.262. So our values are going to be plus and minus 2.262. Okay? Okay. Now, calculating our t-statistic. So I've left this right here in case you wanted to add your numbers again for x and y and find the mean again. But we've already solved for our means of x and y, so I'm just going to bring that over. So we solved for that right here. So x is 3 and y is 6.8. So So your UX and your UY is always going to be 0 here because we don't have a population that we're comparing it to. Finally, your S difference, you solved for this, and so I'm just going to bring this number over as well. So now pump in your equation, open parentheses, mx minus my, close parentheses, minus the 0, divided by your S difference. So you get negative 3.8. So your critical values that we're using in this specific example are going to be plus or minus negative 2.262. Our t statistic in this problem is negative 3.8. So in that case, because the negative 3.8 falls in this critical value region, right? It falls in that purple region. It is less than negative 2.262. We would reject the null hypothesis, whatever it would be, because negative 3.8 falls in the cutoff region of negative 2.262. Okay? So this is how we would make a judgment or a decision based on running some data and running some analysis and calculating our analysis for independent samples t-test. So if I were to make an interpretation of what this decision would mean for us, it would mean that depending on what price tag we give to certain items, even if they're the certain item, people would tend to rate them differently. So that's the type of decision or the real world explanation you could assume for this specific example.